All right, we want to take a look at what we call radicals today. And before we do that, though, we want to talk about prime factorization and prime numbers. Well, prime numbers, if you remember, are numbers that basically only have two factors, one in themselves. In other words, if I give you a number, the only things by which it can be divided are one in itself. One of the first prime numbers, the first prime number is 2. Then you have 3, 5, 7, 11, 13, 19, 23. And they continue on forever. Okay? Now, prime factorization says every single number that is out there can be broken down to basically the multiplication of a bunch of prime numbers. So let's say you take the number 20. 20 is nothing but a prime number of 2 times a prime number of 2 times a prime number of 5. Okay? If you took 50, 50 is nothing but a 2 times 5 times 5. So every number can be broken down to just the multiplication of prime numbers. Now, the way we try to do that is we use what you sort of probably used in elementary school, what we call a factor tree. So if we take the number 60, we're going to break it down. Now, we call it a factor tree because we're going to break it into 2 parts. We think, hey, what 2 things multiply together to give us 60? Now, it doesn't matter what you pick. You could pick 2 times 30. You could pick 6 times 10. You could pick 4 times 15. I'm just going to go ahead and go with 3 times 20. Okay, 3 times 20 is 60. That works. Now, can I break 3 down again? No, it's prime. So that's going to be one of the prime numbers that multiplies to give you 60. So I can't break it down anymore. I can break 20 down, a 4 times a 5. I can break 4 down again, but can you break the 5 down? No. So I'm going to circle it to say, hey, you can't go any further. And then I'm going to break 4 down to a 2 times 2, which those 2's can't go any further because they're prime. That means 60 is a prime number of 2 times the prime number of 2 times the prime number of 3 times the prime number of 5. That's its prime factorization. Again, the factor tree is what we're using to help us break the number down. Let's take 40. If we take 40, I'm going to start with 4 times 10. You could, any 2 numbers that you can think of that multiply together to give you 40, other than don't do 1 in 40. So we're going to break 4 down. 2 times 2. Those are prime numbers, so they can't go any further. 10 is going to break down to a 2 times 5, prime and prime. So 40 is 2 times 2 times 2 times 5. Now, yes, that's 2 to the 3rd power times 5. But we're going to want to write it like this, as we're going to see in a minute. So we use a factor tree to get the prime factorization of the number. Now, as I said, this title is radicals, what we know is a square root. So let's say, just like you simplify fractions, if you have 4 out of 8, 4/8, you simplify it to 1/2. We always want to simplify radicals. So we want to simplify the radical 12. Well, to do that, we have to think what prime numbers multiply together to give us 12. Well, if we do a factor tree really quickly, I got 4 times 3. 3 can't go any further. 4 is a 2 and a 2. So I know 12 is nothing but a 2 times a 2 times a 3. That's what its prime factorization is. Now, a square root means what times what gave you this? Well, if we look right here, the question is, do you see some number that was multiplied by itself? Yeah, the 2. If you have a pair, I always say a pair, it's like a married couple that's inside the house. They come out as one when they get married. They're now one. So these 2 people right here are going to come outside of the house, outside of the radical. And 2 will be out here, and then you will be left on the inside. Who's left behind? The 3. It doesn't have a mate. So square root of 12 simplified is 2 root 3. Let's look at 300. Well, first step I'm going to do is I'm going to break 300 down into its prime factorization. Maybe you notice, well, I think most of us are going to go with 10 and 30. 10 breaks down, again, doesn't matter as long as the 2 numbers multiplied together to give you 300. 2 times 5, that's prime, so I circle it. 5's prime, can't go any further, so I circle it. 30 breaks down to a 6 times 5 is what I'm thinking. 5 is prime, can't go any further. 6 can break down to a 2 and a 3. So square root of 300, here it is. We have a 2 and a 2. So we do have a pair. We have a 3 and a 5 and a 5. Now, we have a couple pairs here. I have a 2, so that gets married and they come out. I have a 5. It comes out. Now, when it comes out as a single one group number, one marriage. You're all as one, as they say when you get married. Now, 2 times 5 is 10 left outside times the square root. What's left inside? A 3. I guarantee you, if you take the 10 times the square root of 3, it'll give you the same answer as the square root of 300. You can check it on a calculator if you want. Well, now let's use that same idea if we're trying to simplify the square root of a to the 5th power. Well, again, always think what something means. What does a to the 5th mean? Well, this means, let's go to blue. I prefer blue. A to the 5th means a times a times a times a times a. Well, do we see any pairs? Yes, here's a pair, so it comes out. Here's a pair, so it comes out. So you have an a and an a that comes out. So what we're going to be left with outside is an a squared, and then left on the inside, we do have a single a still left behind. So the square root of a to the 5th simplifies to an a squared times the square root of a. Let's say we have one that we want the root of 28 to the 3rd. Well, the first thing, I got to break it down. Well, I'm going to have to break 20 down. 20, I'm going to go with 2 and 10. And then 10 will go to 2 and 5. So we know that the 20 is a 2 times 5 times a to the 3rd is a times a times a. So now a 2 will come out. Anything else? Oh yeah, we got an a here. They get married and come out. So I'm left outside with a 2a. On the inside, you're left with 5a. So for problem 4, that simplifies to 2a, the square root of 5a. Well, what's different here? Notice that it has a little 3 there. This is saying they want the cubic root. Now, the cubic root means you need 3 things in order for somebody to move outside of the house. All right, so when we look at this, the cubic root, let's see, I have an a times a times a times a. B to the 6 is 1, 2, 3, 4, 5, 6. This time, though, it takes 3 in order to come out. Well, I have 3 here, so that can come out. I have 3b, so that can come out. And then 3b's here, so that, whoops, remind me tomorrow, that can come out. That leaves us with outside, I have, when I'm cleaning it up, bb is b squared. Make sure you keep the little 3 in there. Be very careful so it doesn't look like it's b to the 23rd. And what were we left with? We're only left with what inside? A single a. Now, the other thing we got to learn is we have to remember about imaginary numbers. The square root of -1 is equal to I, the imaginary number. So if we're doing this problem 6, we're going to go ahead, 18, we do a factor tree. When we do it, notice we have -1. Okay, we know -1 times 18 is -18. 18 will break down to a 2 times 3 times 3. I'm doing that for you. A. Now, what's going to come out? Well, I see a 3 is going to come out. An A is going to come out. Okay, they're going to go out. And that set of A's are going to come out. The -1 will also come out because you and I know that that's worth what? That's worth an I. Cleaning this up, here's what we're going to do. We have 3a squared, okay? And then if you want, I'm fine, you can just put a little I right here. And then we simply have who's here? A 2, okay? Now, we sometimes will want to do that. The other thing they will do, 3a squared root 2. I'm not going to do, you don't have to worry. and then put the I out here. Either one is fine. I am perfectly fine with right here, and you don't even need to worry about your parentheses around the 3a squared. So this is how we end up dealing with radicals. Hope that helps you.